Welcome, I'm Kumar Tangamuthu, Senior Product Manager for Decision Builder. Today we are going to build and deploy the ultimate 8-step AI decision agent for credit card fraud detection. We'll construct this complex decision flow from a blank canvas, ensuring every rule, script, and model is perfectly linked and deployed. We start with the Python code file for date time and shipping billing zip code mismatch feature engineering. This extracts hour and day. We drag it to the canvas, link it, and click Add Missing Variables. Next, the rule set for feature engineering. This calculates the transaction amount ratio and categorizes amount dormancy into groups such as recent, medium, and long based on days since last transaction. We link it and click Add Missing Variables again. We follow with our 3 sequential Python code files dedicated to one-hot encoding. Each script handles a specific categorical variable such as payment device, transaction groups, and transaction day of the week. After adding each node, we click Add Missing Variable to update the flow. Now for the scoring core, we add the ML model node and select our pre-trained random forest model. A final click of Add Missing Variables pulls in the essential probability class 1 score. This score is the foundation of all subsequent policy decisions. We use that score to drive a multi-level decision, starting with the first branching node for high risk. The threshold is set at 52%. If the score is higher, the transaction takes the S path for urgent review. The no high-risk path leads to a second branching node, checking for medium risk. If the score is greater than 40%, it takes the S path for specific review. On the S path for high risk, we apply the high risk review rule set. This enforces a strict policy. If the transaction amount is greater than $350, the fraud flag is set. Policy overrides the score here. The medium risk path applies a dormancy rule set. If the account is medium risk and dormant over 60 days, we flag it for review, targeting a specific misuse pattern. All paths converge to the LLM integration Python code file. The script receives the final flags and generates a natural language explanation via an external API call, adding human-readable transparency to our complex automated decision. Before executing, we click Validate. This confirms every connection and variable across all 10 nodes. Validation successful. We hit Run, select our lakehouse input data, and the entire multi-stage flow executes. The job is complete. We check the output table, and there are the results: the final probability class 1 score, the fraud detected flag, and the LLM explanation. The full auditable output of our complex decision agent.